How's it going, everybody but Nathan? Because Nathan is the only one here today, isn't that right, Noah? No. All right, we are on the second half of 7.2. We're talking about using p-values or probabilities to complete a hypothesis test instead of a z-score. So if you remember, on the last two examples, we were basically making a null and an alternative, and then setting up an example, and then we would compare a z-score to like a z-score edge. And it would either like fit in it or not be in it, right? But now what we're gonna do is with p-values, we compare the probability to this 0.05 and just talk about whether it's less than 0.05 or if it's greater than that. So it's pretty straightforward. Okay. All right, so steps. Step one is exactly the same as step one in this one. Verify that sigma is known. And then it has to be normal, or n has to be greater than or equal to 30, because that's the central limit theorem. And this is in the problem. Nathan, I'm going to start zipping, so you tell me when I'm going too fast for you. Next up is stating the null and alternative. Remember that h sub o has your equals to, or less than or equal to, or greater than or equal to, where h sub a is not equal to, or greater than, or less than, and either can be the claim. Next, we find the standardized test statistic. So this is where it differs. Which is z equals x bar minus mu over sigma divided by the square root of n. I need to get a better song.
I don't know, I think I like it.
Okay, so then you find the p-value. For if it's left or right-tailed, or right-tailed, it's the area in the tail. So you have to use A16, A17 for this. And if it's two-tailed, it's the it's 2 times the area in one tail. And then you accept or reject the null. Why am I writing of so much today? If the p-value is smaller than alpha, or, well, it never will be equal to. If it's smaller than alpha, then reject the null. If p is greater than alpha, accept the null. All right, who should I pick on? Who should I ask a question to? Let me think. Who should I ask? I'm gonna pick, this time I'm gonna pick Nathan. Not always though, don't worry. Nathan, why do you think that we don't care about when the p-value is equal to alpha?
That's a good question.
Give up?
What would the alpha be again? That would be,
So the alpha could be like 0.05 or 0.1 or 0.01, depending on what the alpha in the problem is.
okay. Yeah, I don't, yeah.
So the p-value is like the area in that tail, right?
Mhm.
And it would never be exactly 5% because it's real life data. So real life data would always be like a hair above 5% or a hair below 5%. As long as you go to enough decimals, the chances that it would be exactly 5%, 0.000000, and never any decimals is impossible. It would likely fall on one side or the other. Okay, now after you accept or reject the null, you accept or reject the claim. Which means you need a context sentence. Okay. How about I do one and you do one? I'm good?
Sounds great.
You can have any prize you want. Okay, in auto racing, a pit stop is where a racing vehicle stops for new tires, fuel repairs, and other mechanical adjustments. The efficiency of a pit crew makes these adjustments, can affect the outcome of a race. Have you ever seen that happen? The pit crews change the stuff? It's ridiculously fast.
Yeah.
A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. Okay, so let's start. First of all, first thing we have to do is we have to verify that sigma is known. It says that the population standard deviation is that. So I'm going to write here that sigma equals 0.19 seconds because we're not calling it O-tail. Isn't that right, Nathan?
O-tail?
No, sigma. And then it has to either be normal or we have to have a sample that's bigger than 30.
It's bigger than 30.
Yep. So actually, it doesn't even matter. Like, if it's bigger than 30, you don't even have to check if it's normal, because it's normal or bigger than 30. It could be normal and bigger than 30. That'd be great, but. All right, null and alternative. H sub O, H sub A. They claim that the mean pit stop time is less than 13 seconds. Should that be the null or alternative?
Alternative.
Less than 13. That's the claim. Opposite of that is greater than or equal to 13. Okay. All right, next we're going to draw a little picture just so that we understand it completely. Alpha is 0.01. I do not have to figure out what that rejection region is. Would this be left-tailed, right-tailed, or two-tailed? It's the alternative.
Right tail.
Alternative, so it'd be left for this
Oh.
one. So here, I'm just gonna write alpha equals 0.01. Remember, that's not a z-score, that's just what percent is in that tail. Okay, now we're gonna do x bar minus mu divided by sigma divided by the square root of n. And so it'd be x bar. It looks like they had a sample mean of 12.9. What do you think? Is that going to be enough to say that it's less than 13? I doubt it, especially with 0.01. If it was like 0.1, where we were willing to be a little wrong, that would push it over a lot more. 0.19 divided by the square root of 32. Or if you're Nathan, you multiply it by the square root of 32 and then divide by 0.19.